What's up everyone? JP here with JP Street and Performance. So we are back on the Willys project. The last video we got you guys, we kind of semi-stabbed the motor in there, just kind of roughly where we wanted to be seated. We realized we're gonna have some steering clearance issues, but today we're gonna actually try to get the factory engine mounts off the block and start to design our own engine mounts. We picked up some bushings for our engine mounts, and then we're gonna design them in CAD, and then we'll cut them out on the new Eastwood CNC machine, and then we'll weld them in and get them all squared away. We wanna make sure we get the pitch, angle, and everything of the motor exactly right. Want a nice 3 degrees on the tail shaft of the transmission. He's gonna end up changing the rear axle and the front axle, so he can match his pinion angle up and stuff from there. But we'll go ahead and get this video started, you guys. All right, so one of the first things we're gonna do is that strap we placed under the motor, we went ahead and tightened it up a little bit more because it was wedging on these motor mounts, which my chain is connected to. So we lifted it up, tighten that strap so it would lift up. Now we're gonna take this chain off the motor mounts. We're gonna find a suitable position on both front cylinder heads to lift the front of this motor and to find our pitch that we need, and that'll give us room and access to these motor mounts with the chain out of the way. So we're gonna go ahead and get this chain off, and then we'll start doing the centering of the engine block here. Okay, so our chain is a little wedged, so I had to put a secondary chain on here to lift up so we can get our lower bolts here. A little bit of a tight fit, but so go underneath and get this broken loose here. Here we are. Okay, we got the nut and the washer off. Set these aside. Now I'll try to get this chain off. There we go. All right. Okay, here's the nut and washer. Here is the bolt itself. Set that up here. May need it later. This chain should be able to come out over here. I'm still kind of hung up on that side, so I'm gonna feed it all the way over here and see if we can get it unhung. I may have to lift the motor a little higher. Chain down. There we go. Yeah, so right now we're just hitting on the looks like possibly a brake line, but let's see if I can wedge this past that. There we go. Okay. There's the bolts. The motor mount is no longer resting on anything. We just have our chain currently wrapped around a bunch of stuff, but we'll kind of feed it down through. Okay. There we are. Oh, I see. So currently our chain is sitting on top of our strap that's holding the engine up. There we go. One chain out of our way. So it's actually looking pretty dang good right now. I'm gonna go see if in the big shop I have a engine leveler. That way we hook it to the chain in 2 parts and then adjust it. Slant wise, we can just use a regular floor jack for the slant on the transmission tail shaft back there. So let me go see if we have an adapter and then we'll move forward. Okay, so our chain we have on both cylinder heads here. We are on the same exact bolt on both cylinder heads. These heads can be used for either side, so the castings are the same on both sides. So we're on the topmost outer bolt on both sides, so that should be centered with the chain. Now what we're gonna do is we're gonna count our links starting from the bolt. 1, 2, 3, 4, 5, 6. Let's go 7 links. No, we'll have to get a smaller bolt for this. So we're gonna go 7 links to each side of this chain from that bolt up 7 links, bolted onto the same length of the chain, vice versa, and that'll give us a pretty accurate, pretty close level for this, and then we can take this up higher and then level it out left to right. I did have to switch my chain around. These are meant to be used lengthways, so I flipped this around so that way my hook would go sideways, so we could go sideways here. So pretty simple to do. Here we are. We're actually going to go up to 8, I believe. 1, 2, 3, 4, 5, 6, 7, 8. We're going to go ahead and go right into this bracket. Okay, same thing on the other side. One, 2, 3, 4, 5, 6, 7, 8. Now I'm going to tighten these down. Okay, grab a wrench for the back side there. Okay. Okay, now we know there's no extra unnecessary play. Okay, there we go. And first thing I'm going to do is I'm going to put some tension on the chain. All right, and I can kind of already see it needs to come over this way. There we go. about there. It's a rough visual estimate of level. So how we're gonna tell if this thing is actually level is once we get those motor mounts off, we can use the V of the motor to verify that our angles from the ground are the same. So we know if the motor is sitting this way, that angle is going to be different than that angle, vice versa. So we need to make sure since it's a V6, that they're at the same angle. All right, so one of the first things I want to do before we get too ahead of ourselves, even though this differential is not going to be the one being used, we do want to see, and we can actually roll this forward to level this out, but we do want to see what angle this is at, so that way we can set the transmission angle similar to this pinion. Let me roll this forward just a hair, get some leverage. Let's see roughly where we're at. Okay. Okay, that gives us a much better surface to check. So let's zero this out. It's still at 0.00. So let's zero this out. Come forward, off by 1 degree. Oh, back. Oh, sweet spot. Changes quickly. Right there. 0.00. Oh. As the tire deflects, it's getting us a little bit closer. Oh, come on. Okay. There we go. Now we have an actual true surface. Okay. Earlier I mentioned 3 degrees was what we were shooting for. The factory pinion, I don't know if you could see that, but it's 3.00, dead on the money. So now we know what we need for the transmission. I can tell from back here that the motor's still twisted this way quite a bit. I just want to get a rough estimate on our angle here. This is being held in by a strap. Obviously, it's going to change. So we're going to calibrate. Okay. Currently, we are sitting at 4.5. So our angle here currently is too low. So if we went up just a hair, we'd have R3. Now, overall measurements, this whole system needs to come down quite a bit. So what I'm gonna do is get a block of wood, go get the tranny jack, set it in here, bring the whole unit down. We're gonna get those motor mounts out of the way as we spoke of, and then start going from there. Okay, we want to start with, got the strap out from under the pan of the transmission. We got a block of wood holding the transmission up now with the floor jack. Want to slide in here without hitting our head on too many things and see what we need to remove these factory motor mounts It looks like I can also, for now, temporarily, move our current strap because I have enough tension on the chain up front, and we're triangulated. We have the jack plus the cherry picker, so we're gonna go ahead and remove this strap now to get it out of our work area. I guys don't know, probably can't see a lot of this, but I'll get this off real quick and then probably put you on time lapse. There is 4 bolts to the factory motor mounts. We want to yank those off real quick, so we're going to do that on both sides, and then we can start to design our motor mount brackets. We actually decided to go ahead and get these exhaust manifolds out of our way for now, just to give ourselves a little bit more room to work. So getting to the motor mounts and building the brackets much easier, as long as none of these exhaust bolts break. This manifold's got to come off regardless because of the steering. We'll have to design that. Right, I think that's enough. There we go. All right, we got one manifold out. All right, here's our motor mount. All right, and this one we're gonna have to unplug the oxygen sensor because it is, what's the word I'm looking for? On the lower half of the pipe here. And so I figure out how this little tab gets depressed. Well, maybe it comes up. Screwdriver. Yep, let me go. All right. Oh, that's it. Just that. And then I believe just that. This thing should unplug. There it is. Okay. This gives us much more needed room for our fabrication purposes. And then okay, bolt, gasket. Hopefully we can sneak this manifold out of here somewhere. I guess rid of some of this harness for now. There we go. Battery terminal. All right. It's coming through. There we are. was a pain in the butt. These bolts were corroded in there. Didn't want to come out very easily. But they finally came out. Here's one. Now I got to yank off the other side. All right, got the motor mounts out of the way. So now what we need to do, that's the driver's side there. Here's the passenger side. I see through here. What we're going to need to do is trace out our pattern. This pattern here is going to be for our new mounts. So it looks like they're using a, what gauge is this? About an 8 gauge, which is a 0.172 for their base plate. Now granted, their base plate has reinforced beads and shapes in it, so we're going to go with a thicker material than this because we don't want to use something that thin on a motor. So, well, shucks, apparently it didn't record all my explanation of anything, so here we are. I got this drawn out already. So what I ended up doing is I ended up taking a measurement from end to end with a micrometer, so it's super accurate. And then I also took some measurements from the outside to the outside, inside to the inside, hole diameter as well on all directions just to verify. So the more points you have when you're working with CAD, the more points you have, the more accurate your machined part or your CNC part's going to be. So yeah, it's a few extra steps. You could get away with just knowing the diameter here, then finding center and go center to center, that type of thing. I like to do it a little bit overboard, get all my measurements, and then we went ahead and we measured our bushings. These are going to be our new motor mount bushings here. We measured them this way and we measured them this way. So we have that, and then I also need to know my actual, let's make sure this is still zeroed after bumping it around a little bit. Okay, so we should have this should be 2.5 when you squish it down. 2.5. See, yeah, look at that. I have 2.51. It's 2.525. Okay. And then I need to know this distance as well. Bushing sleeve is 2 inches on the dot. Sleeve, I'm just going to write that, sleeve, 2 inches. There we go. So now what we'll do on this video, we need to make these up so we can get them positioned on the block, so we can get the block back down. Those will be our flat plates to find the exact angle we need for the pitch of this engine. So once we get those plates on there, we can put our magnetic angle finder and make sure the angle of this V is equal to the angle of that V. And then we'll know that the engine is the right direction, and then we can get it back down and start getting the transmission situated back at 3 degrees, back at the height we need. We got to deal with the clearance, clearing the crankshaft, making sure that the front drive line will clear, all that kind of stuff. Make sure this motor's sitting down low enough to where it's not too extreme of an angle from the differential to the back of the transmission transfer case. All that's got to be thought of. So very methodical, very time consuming, but this is where we're going to start now. We're going to take this video inside. We're going to start to do some screen record of working on our CAD. And then we'll end the video for today on that. We need to push the Willys out, pull the CNC machine out. We'll cut these pieces out. And then from there, we'll take the measurements from the frame itself, design. We could probably do cardboard design what the mounts are going to look like coming off the frame, going to the engine block bushing itself. So stay tuned. Let's get some CAD going. All right, you guys, we're on Fusion 360. We're going to go ahead and start with just a top view. It's easier to work 2 dimensions in top view. I did all the math prior to this video, and I didn't realize it was not recording my extra windows like my sketchpad and a couple other things, so you'll have to bear with just the simple dimensions. It's not got any of the pop-ups coming up. So with my math, I did center to center 120.828 millimeters and vertically 91.846. Those are going to be the center of our holes for our motor mount bracket that we're building. Go ahead and select the center circle profile. In this, we're going to leave a little extra tolerance. We're going to do exactly what the original motor mount had. It had a little bit of play, a little bit of tolerance there, so we're using 10.922 millimeters for these circles. And once we finish all 4 of them there, and basically you can see how we're plotting this out. We want to give ourselves enough material around the bolt holes so that they don't snap or break off. So I think if I remember correctly, we're doing basically a little bit more material than what was on the factory motor mount. If you go back in the video, you can see how thin the factory motor mount was, where the bolts actually clamp down. So we're giving it a little extra material. So basically right now, what I'm doing is I'm adding key points to my sketch. And if you remember earlier in the video, I had said that the more points you have, the more accurate your cuts will be when doing anything with CNC or with AutoCAD in just general. So what I'm doing here is I'm taking from the center of the hole out to get the original, I believe it was 5.7 inches or something like that off the top of my head for the bracket. So this is going to make our dimensions of the bracket on the outside relatively the same. And so what I'm doing here is I'm leaving a gap on the corners for now, and I'm just building my outside edges. So this is the fillet tool. We're going to go ahead and fillet the corners. It just kind of preemptively curves all the edges for you, and then you can set the diameter of the the radius of the bend. So with this, it makes it nice. I believe I should pop up here shortly. I want to say it was 5 or 10 millimeters for the radius. Again, my little pop-up windows aren't showing up, which would be
the exact measurements, but I didn't realize when I was using Windows screen recorder, it wouldn't record the little pop-up windows. That's why you see my mouse pointer just randomly go into certain places. So here is an extruded part. We're using 3/16 material. So we set our part to that thickness so we could see what it looked like in 3D space. And we'll go back to the sketch. And what we decided to do is we decided to go ahead and put 2 slits, 2 inches wide, or I should say 2 inches long, and a little over 2.5 inches apart. So right here, this is a really nice, easy way. We're using the construction lines, so these lines don't show up. They're simply just for measuring. It's a really good feature of AutoCAD, and most CAD systems have sketch lines, but it'll help you find the center points of your lines there, so it makes it really nice for working outward. So the way I do it is I usually find my center points, and then when I want to do a measurement, I'll split the difference. Like you'll see here, I'm gonna split the difference for the motor mount bushing that we're using. It's 2.5. I think I have it written down here. 2.525 inches apart, or end to end, and so I think I left a little bit of room for tolerance, and so what I'm doing is I'm splitting that difference of that, whatever the 2.525 inches converts to millimeters, and then convert that divided by 2 basically, which is my 32.068 distance, and I think I have like 3/100ths of a thousandths or something, or 3/1000ths an inch or something of tolerance in there, so kind of added in just a little bit. I always add a little bit of tolerance because the motor mount, as you weld it, it may slightly move a little bit, and also you want to be able to slide the bracket over the actual bushing itself, so you don't want it just super dead tight, so leave a tiny little gap in there. And then so from here, what I'm doing is I'm going up from that point 1 inch, and then I'll go down from that point 1 inch, which will give me a 2-inch wide slit in my bracket, and you'll start to see it develop over time here on the screen. You'll kind of start to envision it as it comes together. Spent a few hours on kind of coming up with the design in my head. It seems pretty simple, but then also with all the measurements and converting everything to millimeters. Again, I could be using inches, but everything right now is just set to millimeters. So once you make your points, you can just connect them. I accidentally forgot to uncheck construction line, but what's nice is you can just go back in there, click on the line. You'll see here, click on the little construction dotted line and convert it to a solid line. There's one there, right there on the right side as well. Once you get them swapped over, you'll see that it will take your part. See, it's all blue right now. It will actually cut that out as a whole. It's got intuitive software that actually, when you make a design in a design on a 2D plane, it considers it a whole. See, as you can see, it's white right there, so it's actually open. So we're going to repeat that exact process on the right hand side for our distance, and we have a tolerance of our material. I took the micrometer, and our material is 4.673 was what it comes out to. So as you can see there, we have it set to 4.675 on the width, so that way when we do our little motor mount tabs, they will slide in, because we're going to weld them from the back side and the front side, but we want them to have a little bit of tolerance in there. Very, very, very minor. And so this is, once you do one side, the second side moves a little bit quicker. So this side's almost done here. So now you can see we now have 2 slits. So we'll look at that in the extruded model, 3D model here in a second, and it'll come up for us. There you go. There is our motor mount bracket. I did find later on, I ended up going back out there to take a couple more measurements and realized that I needed to clearance the what would be the bottom of the motor mount bracket. So near the end of this video, you see I kind of redesigned that square. It's no longer a perfect square, but that'll come up at the end. So here what I'm doing is I just started a whole new file, a new sketch, and I am designing the tabs that will slide into those slits on the plate, and these tabs will go down and hold the motor mount itself, the bushings. So, and what I'm doing is our material again is 4.673. I am going to have a 5.0 millimeter lip, so it'll actually go all the way through our bracket by about 1/4 of a millimeter. So it'll stick out just ever so slightly out the back, which will make it really nice for welding. We can kind of melt it right into that bracket really clean, really nice. And then so I'm also adding a 1/4 inch, 6.35 millimeters is 1/4 inch. I'm adding a 1/4 inch lip or overhang on the top side of the mount, so it'll give it structural strength. Not only will we be able to weld from the bottom and top, but this will also give it strength. Just like an anti-twist kind of just a little extra strength in there. It'll also allow the piece just to sit down, and once it's touching, it'll be, we know it's flush. It should be squared. So, and then I went up. Our bushing we are using is basically a 2-inch diameter by basically a little over 2.5 inches wide. So with a 2-inch diameter, we know that our center line is 1 inch. However, I didn't want the mount to touch the plate, so I went ahead and I did an inch gap between the plate and the mount. So there is actually 2 inches from basically the where the hole is to the plate. And then you can just use this center circle tool to kind of create your design, and then this little tangent, little omega looking symbol there is actually really nice. It'll, when you're doing a line to a circle, it'll tell you where it will disappear into the circle properly. You see I'm searching for it there. There it goes, and then it gives you that little symbol. So that it actually disappears into the circle, and then we're gonna fillet these edges here, and that's a R10. As you see there, that's a radius 10. So do that on both sides, and take our trimming tool, clip this out. There you go. Now we'll convert this into an actual 3-dimensional piece, so you guys can see it in 3D. Those will slide down into those tabs we made on the plate. And finally, we have just a 3D visual of what the assembly is going to look like right here. And this shows you the plates and the tabs, and then the motor mount bushing will obviously go in between those two tabs. This will bolt to the block, and then we will later design the actual mounts that go to the bushing to the frame. But that's what it's going to look like. Thanks for watching, guys. I really appreciate it. If you like this kind of content, we're kind of learning as we go, and we're getting pretty good at this Fusion 360 and using the CNC machine. So please like, subscribe, and leave a comment. It really helps promote the channel.